Okay, in this video we'll be looking at Unit 2B, which is extending our unit analysis. And in here we're going to be looking at units in what we call the U.S. customary system, which are units that we're used to: inches, feet, yards, miles, etc. We're also going to be looking at the metric system, which is in meters and kilograms, milligrams, all sorts of different types of units that we can deal with in there as well. Now this first part that I've got here, you can pause the video, you can read through a little bit of the history of where the U.S. customary system comes from, where it dates back to. It is a very complex system, and it's very foreign to other places, but this will give you an idea as to where all of this actually stemmed from. And here are some of the what we call the conversions, or our equivalent factors here. So for example, if we're we got 1 foot is 12 inches, 1 yard is 3 feet, 1 mile is 5,280 feet, 1 nautical mile is 6,076.1 feet. And there's also a little bit you can see, we've kind of mixed in here a little bit of the metric system. But again, we can see that the U.S. customary system is quite large. So we've got lengths, weights, and volumes. And this is not something you necessarily have to have fully memorized. I mean, obviously knowing that a foot is 12 inches, a yard is 3 feet, a mile, 5,280, that's a pretty good one to know. But just knowing some of the generalities here, on weight, a ton is 2,000 pounds, 1 pound is 16 ounces, and so forth. We're not going to be doing tons with the volumes. We'll be using a little bit in gallons and things, but again, you don't have to have this whole thing memorized. We're going to use it to do certain analyses of units, conversions of units in different application problems. So this will be a helpful reference for you. Okay, so we're going to look at again, as we're extending our unit analysis, we're just kind of picking up where we left off in our last unit, and just adding a little bit more to that. So this problem says that 1 cubic foot holds 7.8 or 7.48 gallons of water. Okay, so I'm going to write that down. 1 cubic foot holds 7.48 gallons. 1 gallon of water weighs, 8.33 pounds. So I'm just writing down the information I know as I go. And it wants to know how much does 6 cubic feet of water weigh in pounds, and then in tons. So we got a couple of things we need to find out here. So we're looking at 6 cubic feet, and we want to know how much does that weigh in the end. So we have 6 cubic feet, and then we're going to times it by our conversion fraction here. Now we know that, let's see here, 7.48 gallons is 1 cubic foot. So that's going to cancel out our cubic feet units. And then we know that 1 gallon is 8.33 pounds. And again, notice I'm specifically putting my fractions so that my units are going to be canceling out here. And so what happens in the end is I have 6 times 7.48 times 8.33 pounds left. The bottom of the fraction is just 1 times 1. So when I multiply all of that out, I get approximately, rounded to the 10th place, 373.9 pounds. So 6 cubic feet of water here is going to be 373.9 pounds. Now, if we want to go for tons, okay, remember the conversion that 1 ton is 2,000 pounds. Change colors for this one. So we know we've got 373.9 pounds. We're going to times that by, I want pounds in the bottom, and 2,000 pounds is 1 ton. So that's going to cancel out the pounds. So we're going to have 373.9 tons, and this is over 2,000. So when you do 373.9 divided by 2,000, you get approximately 0.19 tons. Okay, so 0.19 tons is equivalent to 373.9 pounds, which is 6 cubic feet of water. So again, that's using unit analysis to find out the values of units in, when we're given a scenario, we're going to find different values using different units, because some things, sometimes you would need cubic feet when you're dealing in a volume setting. Sometimes you're going to need pounds when you're trying to, determine if, say, for example, a truck can carry that amount of weight and so forth. So that's where this may come into play, but that's how you would do that. Again, an extension of our unit analysis. Now we're going to look. We've got the International Metric System. Okay, so the metric system, a little bit of history given there at the top, invented in France in the late 18th century. And one of the big things was to simplify these conversions through the use of a base 10 system. And what it means by base 10 system is we can basically just say we want to go from kilograms to grams. We can actually just move our decimal place, and we'll see that. But the basic units here for length, mass, time, and volume, you can see those are respectively meters, kilograms, seconds, and liters. So when I talked about basic units, those are our basic units that we use for length, mass, time, and volume. Okay, and all of these are going to be using prefixes. So for example, prefix kilo means 1,000. So a kilometer is just 1,000 meters. And we can build that up. So here are some of our common prefixes. I've got a couple of tables here. You may prefer one over the other. This one on the right is specifically dealing with meters or length. Just to give you an idea. But your prefixes, so you have, if we're building up, so again, we started our unit, which if it's length, we'd start at meters, and then we go up to a decameter. Okay, that would be 10 meters, and then a hectometer, that would be 100 meters. A kilometer is 1,000, and then we start to jump here. A mega meter is 1 million meters. So you can see these powers jumping from 10 or 1, 2, 3, and then 6, and then 9. Because these are some of the most commonly used. So giga is billion, tera is trillion, and you may have heard those words a lot. Megabytes, gigabytes, terabytes. That's a different unit in storage capacities, and that just tells you how big size or value you have. Okay, now if we go the opposite way into decimals, we have deci, which is a tenth, centi, which is 1/100th. So like, for example, 100 centimeters is 1 meter. Then we go millimeters, which is 1,000. Then we go down into micro, which is to the 1/1,000,000th. Nano, 1/1,000,000,000th. And pico, 1/1,000,000,000th. So couple that we do hear frequently is we hear nanotechnology. Okay, that's down on the 1/1000th scale. Microtechnology down on the millionth scale, and so forth. And so let's look at this. Let's got a couple of problems for us to solve here. We want to convert 24 kilometers to meters. So we've got 24 kilometers. A couple of ways you can do this. Okay, you can times this by, and you can say, well, again, I want kilometers in the bottom, and 1 kilometer is 1,000 meters. And again, that's kind of right here. So our kilometers cancel, and this would be 24,000 meters is 24 kilometers or kilometers. Okay, another way that this is done, and this is what's nice about the base 10 system, is if we start with 24 kilometers and we want to go up to meters, well, we know that kilometers are bigger than meters, so then we know our number is going to be getting bigger, and it's kilo is 1,000 times bigger, or 3 decimal places, so we move that decimal place 3 places to the right, and you get 24,000. And that's the nice thing about conversions in the metric system, is you can simply just move your decimal to the right or to the left, depending on whether you're getting bigger or whether you're getting smaller, and how many degrees we're jumping, whether it's 10th, millionth, billionth, thousandth, and so forth. So the next one, we want to convert 1,380 nanograms to milligrams. Now, nanograms are they are much smaller than milligrams. Okay, because again, our milligrams were in the thousandth, nanograms are in the billionth. And so when you look at the decimal places here, -3 to -9, that's 6 decimal places of difference. So if we try and look at this in the simplified form, we take 1,380, and we're going to take this decimal and we're going to move it now to the left 6 places, so we get 0.001380. So I'm going to rewrite that a little bit better. Milligrams. Okay, and hopefully that makes sense, because again, milligrams are bigger than nanograms, so we should be getting a smaller number when we go nanograms to milligrams. Okay, the other way you could do this is you could say 1,380 nanograms, and you could times this by, and here's where it gets a little bit complicated, because you just have to check out your decimal places. So let's see, 1, 2, 3, 4, 5, 6. So there's, again, we're going from the thousandth to the billionth, so that's 6 decimal places. So you'd say in here that 1 million nanograms is equivalent to 1 milligram, and then when you do that division there, that's going to give you the 0.00138. So again, moving the decimal place is probably the most simplified way to go about this, but when we're doing big conversions, we'll be using these guys here. But hopefully that helps give you an idea as far as how those conversion factors work, and that they are synonymous. They are the same. Just the work can be a little bit tedious, especially with all of these, pico, nano, micro, and these powers and things. So we're going to go ahead and stop here and pick up in part 2.